Afternoon, everyone, or evening, depending on what time you are watching this thing. We are doing chapter 15 on strength of material. We're gonna do strands or long columns or short columns if you may prefer. Right. Firstly, let's do a basic theory before you even touch on the subject. Right. So you know what is a column, right? So a column is just a beam. This is a column. Yeah, it's just a beam that is placed long by a column is just a beam that is vertical, basically, right? So under strands, we are actually studying failures, right? So you're gonna get into it what different failures are there, right? Let's take a scenario. Let's go back a little, right? Let's say this thing, as you can see it, let's say this thing is a, what do you call this? Let's make it a column, right? You see, it's a column, right? When you push at it, when you apply force on it, the more you apply the force, it's gonna what? Gonna crash. It's gonna be on, it's gonna go down and crash. Yeah, when you, it's gonna crash. You just, yeah, it's gonna crash, right? Take note of this. It's small. When I push on it, it's gonna crash. But now let's change the scenario. Let's take a ruler now. Yeah, let's take a ruler and then apply the same force. Let's say it's the same or whatever force. What happened? It didn't crash this one, but it bent. And we know in mechanics, we know that if it's bent, let's say it's a table and you are, or a chair, and it bent, it's gonna fail. This is a failure because it's no longer suit for the position. You know that when you are sitting on a chair and then the legs of the chair start to bend, you're gonna fall, or the chair is gonna curve and then crack, right? It's a failure, you see. But when it was short, it didn't fail by bending. This one is gonna fail by crashing it. So, but this one, even if, let me pause the video. Remember this graph. This is actually strain. This is what? Stress. Right? Do you remember this graph? Right? So, for this one, the short column only fails when it's above elasticity. You see, when it's above, becomes plasticity or whatever, you know this thing. After yield strength, you remember yield stress. Yield stress is somewhere here. Yield stress, right? After yield stress, this will fail, right? Because the material is no longer elastic, it's no longer able to retain its shape. This will fail. So the more you push it, it's gonna fail at the yield stress. So this one we can actually predict. But for this one, even if we have not reached the yield stress, so the moment we are applying the force, but the yield stress tell us that the yield stress actually tell us where is this material gonna fail. So the moment we push, but we haven't reached the yield stress, but it failed, right? But this fail is not something usual, right? We call it buckling. Buckling is actually another failure. Even if the force that you are applying does not give you has not yet reached the yield stress, right? I want you to understand that scenario, right? Like, just play with it. Yeah, it's just that if it's a short column, it's gonna fail by yield stress. But if it's a long column, the moment we apply pressure, it's gonna fail by buckling, right? And then there are many theories about how do we calculate that buckling, how do we know it's going to fail with buckling, how do we know it's going to fail by yield stress only. So this is all about in chapter 15. That is what we are actually doing in chapter 15, right? So without wasting time, let's go into it, right? There's this first theory by Euler. You go and read the textbooks, you're going to understand Euler. There's this first theory by Euler, which means P is equal to pi squared E. Let me just remind myself the formula. So it's going to be pi squared E over times I, moment of inertia, over L squared, right? There's this formula by Euler. It actually predicts the buckling load. This P, okay, let's just start it. I'm going to explain later. So this P is a buckling load, right? I want you to notice one thing, buckling load. So let's go back to the ruler. So this is the ruler. So as I'm applying P, that is my force, I'm applying P. So this is P basically. What do you notice about the ruler? It already bends. So P, always remember this, P is a load, is a buckling load, is the amount of load that I need to bend this ruler to its maximum. You see, that is P. So every time they ask you for P, P is already what? Failure, is already the failure. So this is a failure. This is an actual failure. Okay, again, let me explain again. So I have a roller here, right? You see, I haven't applied any force, but the moment I applied force, that is P. So P is the force that is required to bend this ruler. So it's already what? What do you notice? It's already failed. So P is a failure. So the moment you apply a force P, it's gonna fail. I want you to understand that it's gonna fail. People, please understand. When you apply that force P, it's gonna fail. Right? So P is a danger. So when you are designing, you don't want P. You know, you need force that is less than P. So meaning what? P, the safety of factor is already included. Why? It's a failure. It's already included. It's like getting, I don't know how to explain it, but you're going to explain it by doing the problems. You're going to understand it by doing, but just know that P is a failure. P is what we don't want, but we now know what is the amount of P. So P is a failure, understand that. So that is one thing. Now let's continue. Pi is pi squared. I'm not going to explain that. E, elastic modulus, or Young's modulus, whatever, or Young's modulus. Let's say Young's modulus of that material. So if they give you steel, they're going to give you the material, whatever, Young's modulus. Then I, this is I, people. This is moment of inertia. Take notes what I'm writing. I said least moment of inertia. Yeah, moment of inertia, or second moment of inertia, or second moment if you like. I said least. Underline this word, least. What does least mean? Least means it's the smallest. Let me just say smallest. Right? But sometimes you must take note of the what to call this, how they describe. If they say the list is hinged, okay, let me first try to explain. Let me just not confuse you. Let me try and explain list. List means what? For example, you have a cross section of this roller, you have longitudinal, you have a depth, and then you have a width. So it's a rectangle, right? Then we have two moment of inertia. We have the moment of inertia from the middle, this middle, and then horizontal. Let me just draw it. So this is the roller. So this is a cross section of this roller. This is the width. This is the, let's say, the depth. Then we know we have moment of inertia, let's say IXX, and then we have moment of YY. Does not matter the orientation. If I like, I will even do this, right? The least one in this case is IYY. Why? When you calculate it, it's gonna be the smallest, right? Whereas IXX, large or big, or whatever, depending on whatever language you are using. So why the least? Why least? Because it's gonna bend by the least. It's just simple. For example, when I'm applying the load, where does it bend by? Bend by IYY, in this case, IYY. If the orientation was like this, it's gonna bend with IXX. So take note of the orientation. So in this case, it's RAXX, IYY in this case. But it does not matter. But you always, that means for you to get marks, you already educationally or by intuition, you know the list is IYY. But always calculate them both. Calculate them both. Always calculate them both. It's very, very important for you to calculate them both, so that you see which one is the smallest. You're gonna use the smallest in the formula. Please, the least is the smallest. Is this difficult? It's not difficult. Then we have L. L is just the length. Hey, forgive me my spelling. Hey, the T is in the middle. The length of the column. So the length, take note, the length is not a cross section. You must always, the diameter, most of the time the dimensions of the cross section are always small. And then it's just the length. So in this case, this roller is 30 meters, 30 centimeters, but give or take because we have added. So this is the length of this roller is 30 millimeters, 300 millimeters if you like. You see? So it's the length. How long is the, right? Yeah, that's it. Then if, for example, the question asks you safety factor, safety load, it's just equal to P over E. Why not over E? Over safety factor. Safety factor. Right? Why? Because safe load is equal to P over safety factor. Remember, this is in Newton. So this is, let's write in with another pen. So the unit is Newton or kilonewton, is up to you. It's a load. Sometimes in other formulas, you're going to find PE, where E means Euler, if you like, right? yeah, I'm done with this thing, but there's very one thing that is very crucial. It's the length, L. It's the length, that L. Right? You must read the question very carefully. Right? So if the question says there are conditions, there are only 4 conditions. We are going to L now. There are 4 conditions, right? With this L, we actually want LE here. What is LE? LE is just effective length. Right? Why? Because if you're gonna say L, per condition, L changes. But L effective, it makes it easy for you. Right? For example, number 1, if both ends are hinged or pinned, same thing. Hinge and pin is used interchangeably. So what does it mean? So we have something like this. Let me just use another color. So we have something like this. Say both ends are hinged or pinned. So we have something like this. You bend it, it's already what? Remember, when you are using this formula, it's already failed. So it's already bent. And then, so this is a pin. This is a pin. Pin. So both ends are pinned. So this is a column basically. And then it's bent. For imagine a ruler here. And then I pin here and I pin bottom. And it's already bent. Right? Every time you are using these formulas, it's already failed. So that you don't remember. So when it's like this, both pin are pinned. So the length is just L. So L is equal to L effective. So L effective is just L in this case. Okay, number 2, let's use another both. Both, so that you write both ends are fixed. Another language, encastrated, I don't know, built in if you like. Yeah, fixed, encastrated, and built in. If it's dead, then let's draw again the structure. Remember, it's already failed, so it's already bent. And then fixed, that means the bottom is fixed. Fixed means built in. So imagine this roller getting into this exercise, and then at top I grab it like this, not pin it, but grab it, so it does not move. It does not move in the bottom, right? But obvious, the top, we apply the load on top of it, even though it's fixed, right? Think of the columns in the house, or in the veranda, or think of those things, the columns, and then you know that it's fixed on the top, it's fixed on the bottom. So so again we have L. So L effective in this case is equal to, if it's like this, both ends, focus, both ends are fixed like this, just know that L effective is L over 2. So whatever length of the beam is given, you just divide by 2 to get L effective. That's what it means. So in this case, if the length is 1, that means the length is effective. Here, if the length is 1, that means length effective is 1 over 2. You get it? Number 3, right? Number 3, you must create the table, you must cram this thing, it must be in your head. Number 3, let's say one of these things is fixed, 1 is free. So what does it mean? It just means this. This is a pole. When you see a pole, a light, light pole, a lighthouse, obviously, lighthouse, something like that, basically. But the lighthouse you cannot apply force. But a pole, most of the time with the stop sign here, it's something like that. It's one hand is free. It's free here, and then because when there's wind, it can move here, it can move there, and then the bottom part is hinged. So in this case, L effective is equal to what? So if it's that, it's just 2L. So if this length is 1, that means L effective is 2. That's what it means. If it's 3, it's 6. If it's 4, it's 8. Whatever. So take note of those things. Then the last condition, let me just write it here in this free space. Last condition, 1 hinged or pinned, and then 1 fixed. So we have something like this. So let's draw it. It's already failed, remember? And then you fix the bottom, you pin the top, right? So we have something like this. Then L effective. So remember, this is L, the length of this thing is from here to here before it failed. So L effective, if it's this, L over root 2. So just know that. Is this thing hard? So basically, my good people, Euler is just direct substitution. Whatever question you get, most of the time you'll be given E. Obvious, I told you this is a list modulus. So you, in a test or whatever, you must calculate them both. But obviously in real life, you can assume. Most of the time you just use educational guess, so you get an answer. For example, this is ruler. There's no need to waste my time calculating IXX in this case, because I know IYY is the least one. So, but in test or whatever, we must calculate them both, right? Then E, obvious, your statement will tell you. If they say both ends are hinged, then you know. If they say both ends are fixed, you know. If say one is fixed, man, it's easy, man. It's easy, Saint. It's easy. It's just direct substitution. There's nothing good. There's nothing to it, basically. So I'm gonna, on this description, let's look at problems we can do, right? You can find this problem on the description. So I've created the problem. You can see. Chapter 15 Strut problem from Strength of Material book by Dr. R. You search it, buy it if you like, right? So these are problems, right? In the book, they have solutions step by step, right? But obviously, we can still do it, right? Let's look at problem 19.1, right? So a solid round bar, long and 5 centimeter diameter is used as a strut. With both ends are fixed, determine the crippling or collapsing load. So the moment they say crippling, then just means P. Why P? Most of the time, if it's short, okay, just know. They just want the crippling load, and then the answer is given this, right? Let's try and draw the structure, right? So what we have, we have a solid round bar. So we have a solid round bar. So you have something like this, right? It's 3 meters, and the diameter, so it's the cross section here, it's 5 centimeter, because they say diameter, so it's a round. So keyword round is used as a strut. Both ends are fixed. So in this case, we can draw it failed, remember, and then say both ends are fixed on. That means there's a pin here, there's a pin here, hinged, right? So there's a pin here, there's a pin here. So it failed. Remember, it's 3 meters. So the moment they say both ends are fixed, go back to your brain. This is your brain. Both ends are pinned. So you know L is equal to L. That means L effective is equal to L, which is equal to 3 meters. Remember, the length is 3 meters. Right? What else do we have? Then basically they ask us to find what? P. Yeah, the crippling load. So they ask us to find P. We don't know P. So how do we do it? Direct substitution. But now, write the formula, but most of the time you have it on your formula sheets. Remember, when you have L effective, always LE squared. Right? We need to find I. It's a circle, man. So this, so IYY, IXX. So if a circle, it's the same. Circle the same. Even if it's hollow, if you like. IYY and IXX are the same in the circle. Even if it's hollow, but you must take note of the formula when it's hollow. So this one is solid. So it's solid. So I for the solid is just what? It's just what? It's pi d4 over 64. Right? Take note of the units, please. So if I'm gonna use millimeters. So it's gonna be 3. What is 3 meters in 3? I don't know. 3,000. Yeah. Millimeters. And then obviously my diameter, 5 centimeters, gonna be 50 millimeters, right? So the least modulus is just, you can even just substitute it in, but let's just calculate it. Pi times, what is D? 54 over 64. Then PE is just equal to, so in this case we are given E is equal to 2.0 times 10 exponent 5 Newton per millimeter squared. That's why I was using millimeters, right? So let's substitute. So I've just calculated it. Notice you see, I get the same answer. You see? Just don't be shocked. Most of the time, the answers are too big. P must always expect it to be too big. It's not normal. Why? Because it's a load for failure. That means safety of factor is already included. Just keep note of that, newtons, right? So if you're gonna work with millimeters, convert everything. Just take note, because this thing can be, say, 2,0 times 10 exponent 5 MPa. Remember E, from here, it's a yield strength of this material. Even though we don't reach the same pressure, the structure fails. So, yeah. This is the answer. Let's go to the next problem. I'm not gonna do other problems. You're gonna do it. 9.2, you're gonna do it and see, right? Sometimes, yeah. Let's see. You see, this one, problem 19.3 has a safety load. Do it also and see. Don't worry. Take note of the dimension. Say the column of the timber 15 centimeter by 20. It does not matter what orientation you like. For example, in 9.3, if you like, you can say this is 15 centimeter, this is 20, or if you like, you can say this is 15, this is 20, because if they don't give you a drawing, it does not matter. So in this case, you must calculate. Oh, let's do it. Let's do 19.3. Yeah, let's do 19.3. Right? But let me not do it. You must do it, because I told you, if for I, you always use the least moment of inertia. So yeah. So peg 3 is 19.3. You're gonna do it. It's easy. Even 19.8, the same thing, right? If you're gonna, while watching my last videos, you know how to calculate IXX. How about IYY? You figure it out. There's one video I showed how to calculate it. So yeah. Let's do Rankin now. So just do these problems and see if you get the answers. I think there's one answer that you're not gonna get. I don't know which of these problems, but do it. Tell me on the comment. I'm not gonna do it. Just do it. Right? Yeah, just try to do it. Figure it out. Use table method to find IXX and IYY. Always. Yes, there is sometimes the reason why they can't. Yeah, the answer of this one is this one. Right? So that's it. So yeah, on Drosky you can do these problems. Chapter 15, or if you like, if you have another version, it's chapter 12. 12.1, 12.2, 12.3, 12, these problems. Obvious, I have to explain the another section wrinkle, but basically this is what you need to know. There's nothing into it. It's just, let's recap very fast. It's just knowing this formula, knowing that I is the list, and then this 4 condition. Yeah, this is number 4. These 4 conditions must be in your brain. Then yeah, basically is that. So when you have this, you must calculate the list. That means in this case, if I did draw it like this, okay, it's fine, XX. So I have to calculate IXX and IYYY. If you don't know how to calculate IXX and IYY, oh God, I'm gonna show you. We're gonna do this problem on its own in the next video, and so that I can, in fact, I'll do the hard problem. Let's see. I'm gonna do 19.10. Let's do 19.10.